So notes 2.4, this is going to be covering covalent bonding. And covalent bonding is going to be different than ionic bonding in that when you have a covalent bond, basically now you're only going to have the joining of two nonmetals. So that means all the elements that we're going to be dealing with are going to be elements to the right-hand side of the stair step over here, as well as hydrogen, because hydrogen, again, is a nonmetal. So all these metals over here on the left of the stair step are metals not involved with covalent bonding, only dealing with nonmetals. And so this is also different in the fact that elements now are going to share valence electrons. There's no giving or taking, but instead we're going to be sharing them. Because if you remember, nonmetals do not like giving up their electrons. They all want electrons. They all form negative ions because they all want to gain electrons. So instead of just giving and taking now, they're simply going to share. So let's do some examples of this so we can kind of see what this looks like. One of the examples and things that we've looked at in the past is hydrochloric acid. And so what we're going to do is we're going to go through just how to show the sharing and the covalent bonds. We're not going to go through the naming yet. That'll be in another time. So if we start with hydrochloric acid, hydrogen and chlorine. So if we look, hydrogen sits right here, right? So it's going to have one valence electron. Chlorine sits right here, so it's going to have 7 valence electrons. Now, what we see is that each element needs one additional electron. And instead of giving and taking, they're going to share, and they can only share what are considered the unpaired electrons. So that's why we're very specific when we do the Lewis dot model. Because what they're going to do is now, if we notice, we have an unpaired electron here, we have an unpaired electron here. So what those two atoms can do is they can actually share. So we're going to show the sharing now by drawing a circle around those two electrons. And what that means is that the elements are going to have those electrons at some point, not all the time, but they're going to get them some of the time. So hydrogen, because it's in the first row, only needs 2 electrons, so it's going to have 1, 2 sometimes. It's going to have 0 sometimes, but at least it's going to have 2 sometimes. Chlorine is going to have 1, 2, 3, 4, 5, 6, 7, 8. So both of them would then be considered full at some periods of time because they are sharing those. So that's kind of the first step here in covalent bonding. The next thing that I'm going to do is I'm going to show that that is now a bond. So I'm going to show that by doing this bar, and that bar represents a single or 2 electrons being shared between hydrogen and chlorine, and then I'm going to add the additional electrons on the outside of chlorine. So when I count around each element, I should be able to have 2 or 8 depending upon which element it is. Hydrogen only needs 2, so this bar represents 2 because it's those 2 that are being shared here. Chlorine needs 8, so it's 1, 2, 3, 4, 5, 6, 7, 8, because there's 2 there. And I'm pretty much finished. And then I'm going to finish with, that's kind of the second step. And then what I would need to do is I would need to do the symbol or the chemical formula, and that's HCl. Right? And so this, let's put this is an example of a single, it's called a single bond. There is a single bond joining hydrogen and chlorine of the sharing of 2 electrons. Okay. If we look at another example, now let's do fluorine. So fluorine, oopsie. So we'll do fluorine gas. So we'll have 2 fluorine atoms, again, 2 nonmetals that are joined together. Fluorine, because it sits here, is a nonmetal, and it has 7 valence electrons. So I'm going to draw this a little bit differently just because I know what's going to happen. I'm going to draw the unpaired electron in between, or on the middle, of the 2 atoms. And so what we can see is that these atoms, if they share these 2 electrons, both of them at some point can have 8. So that's, again, my first step. Counting around, we have 1, 2, 3, 4, 5, 6, 7, 8 for this fluorine, and 1, 2, 3, 4, 5, 6, 7, 8 for that fluorine. I'm again going to show F So my second step is to show that bond between them. It is again a single bond, and then I'm going to show my extra electrons on the outside. And this chemical formula would be F2. And again, this is an example of a single bond. All right. Another example we can look at is the idea of water. So we talk about all the time, oh, that's hard to see, sorry. We talk about all the time that water is H2O. And so showing that water is a covalent bond. Hydrogen is a nonmetal, oxygen is a nonmetal, so we're going to show that process. So we know that there's one oxygen, right? And I'll do 1, 2, 3, 4, 5, 6. And then there's a hydrogen. So when I do this, there's a single hydrogen here, and what I can see is that this hydrogen is going to share the electron with oxygen. Now if I count around, hydrogen has 1, 2, it's full. Water or oxygen has 1, 2, 3, 4, 5, 6, 7. So it is not full, so that's why we need a second hydrogen. So if we do a second hydrogen down here with that valence electron, they can share, they can share those two electrons. And now again, counting around oxygen, 1, 2, 3, 4, 5, 6, 7, 8, and both hydrogens have 2. I'll show the bonding process of this then. It's going to be O. This is a bond with hydrogen, sharing 2 electrons, a bond with hydrogen, sharing 2 electrons, and then we have its extra electrons right here. Right? And the chemical formula for this is going to be H2O. Now this, again, is an example of single bonds. There's 2 single bonds, but it's single bond right here, single bond right here. So this is not a double bond, this is an example of a single bond. So you might say then, well, what's an example of a double bond? So here's going to be an example of a double bond, and then we'll do a triple bond as well. All right, where a double bond is now not going to be the sharing of 2 electrons, but going to be the sharing of 4 electrons. So an example of that would be oxygen joining with itself, and this is going to be oxygen gas. So 1, 2, 3, 4, 5, 6 valence electrons for oxygen. It's in that 6th column right here. Same thing over here. 1, 2, 3, 4, 5, 6. So I'm going to circle the unpaired electrons that can be shared. So we can share these 2, and we can share those 2. And then if I count around oxygen, I should still get 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So they are full shells at least some of the times. This is then going to look like this. Oxygen with now 2 lines in between them, just like that. And then I'm going to fill in my extra electrons. So again, counting around each one, I can do 8. It's going to be 2, 4, 5, 6, 7, 8, 2, 4, 5, 6, 7, 8. And the chemical formula for this would be O2. The last example we'll go through, this is going to be an example of what's called a triple bond. Where, just like in oxygen, when it was a double bond, they shared 4 electrons. A triple bond is going to be an example where they share actually 6. So if we do nitrogen, nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I can show the sharing of the unpaired electrons. So 1, 2 can share. 1, 2 can share. And then a big share here where those 2 can share. And again, what I can do is I should be able to count around the atom and get 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 for each one. All right, so what we'll show that as is we'll show nitrogen with 3 lines in between, and then its extra 2 paired electrons on the outside, and that's going to be an example of N2. All right? So we'll go through the naming process a little bit later, but this is just an example of how we would do the different types of bonds.